Hello and welcome back. In this session, we'll be looking at a beam element with a number of point loads, one angled. The beam is simply supported with a pin support and a roller support, so a mixture of a few things here that we've already covered, but we'll put together in this exercise. Let's get to it. Okay, this is the exercise we'll be solving now. As you can see here, it's a beam, AB, with 3 point loads, 4 kilonewtons at a 45-degree angle, 10 kilonewtons, and then a point load of 2 just above support B. The first thing we need to do is create a free body diagram. To do that, we need to address what kind of supports we have at A and at B, and draw in the reaction forces. Starting with A, we've got a roller support. When we have a roller support, it's one reaction force, which is drawn perpendicular to the ground. So perpendicular to this direction here. So as you can see, in this case, let's get rid of the support. We only have AY. At point B, we have a pin support. So we can get rid of this pin support and draw in our two forces, BY and BX. And I'm just drawing these in the positive directions of the sign convention that we agreed on. Before solving the reactions, I'm going to look at this angled force of 4 kilonewtons, and I'm going to divide it into its components. So I've got a component here along X, and I have a component here along Y. And as a reminder, this angle here is 45 degrees. So dividing into components, this X component is going to be 4 cos 45, which gives me 4 times a square root of 2 divided by 2. So 2 a square root of 2, which I can also write as 2.82 kilonewtons, just depending if I'm working with a square root or not. And since this is an angle of 45, we know that Fy, which is going to be 4 sine 45, works out exactly the same. So 2 square root of 2, or 2.82 kilonewtons. To make my life easier, I can just replace that on the diagram. So let's do that. So I'm just getting rid of this 4 kilonewtons and replacing it with a force Fy of 2.82 and a force in the x direction, also 2.82. And now I'm ready to solve the reaction forces. Let's start off with a sum of forces in the x direction, with this being my positive x. So in terms of support reactions, I've got Bx in the positive direction, plus that component of the force we just discussed, 2.82. Nothing else in the x direction, so that equals 0, and that means that Bx equals minus 2.82 kilonewtons. I can now move on to the sum of forces in the y direction, with this being my positive y. And in this case, I've got AY plus BY. Those are my two positive reaction forces. Then, starting from the left to the right, I've got minus 2.82, minus 10, and minus 2. And all of those together have to equal 0 for this to be in equilibrium. So that means that AY equals 14.82 minus BY. And in order to solve everything, I need to take into account the moments. So I am going to do sum of moments around B. And that is because at B, I have two forces, and I also have this force of 2. And you can see that this force of 2 also passes at B. Because it passes at B, there is no distance, meaning that it cannot contribute a moment. So the 2 can't contribute a moment, Bx can't contribute a moment because it passes through, By can't contribute a moment, and if we look at this 2.82, we can see that it also passes along the beam. In order for the 2.82 that I've just highlighted to have a moment, it needs a distance, and that distance needs to be in y. We don't have a distance in y, therefore that also doesn't contribute to moment. So contributing to moment, let's do that in a different colour. I've got AY, this 2.82, and this 10. So now that we know what contributes to moment, let's go ahead and calculate it. So starting with AY contributes a negative moment, so minus AY, with a full distance, so times 7. And it's negative because if I look at the direction of travel, so AY goes up in this direction, it has to get back to create a moment around B, so it'll have to travel back to B, and that means it's giving a clockwise moment, which in my sign convention is negative. The 2.82 gives a positive moment, so plus 2.82, and the distance here is the distance in x, which is this distance, right? This distance in x from the point of action, or from the line of action to point B. So that is 5. And the last thing I have is the 10. In a similar manner, the 10 gives a positive moment with a distance of 2, and that equals 0. So I've got 7 AY equals 34.1, and if I divide both sides by 7, I get that AY equals 4.87 kilonewtons. Now that I have that, I can go back into my second equation, so this one here, and figure out what BY is. Should have probably written this the other way around, but BY equals 14.82 minus AY, and therefore BY equals 9.95 kilonewtons. The very last thing that I want to do is a quick check. I'm going to do the check by summing the moments around A this time, with this being my positive direction. So let's see what I have around A. Let's just discuss first what contributes to moment and what doesn't. So around A, AY does not contribute to moment. 2.82 passes through A, so also doesn't contribute to moment. BX passes through, so doesn't contribute to moment. So what we have contributing to moment is 2.82, 10, 2, and BY. So let's check this out. 2.82 contributes a negative moment with a distance of 2. The 10 also contributes a negative moment around A with a distance of 5. The 2 at the very end at B contributes a negative moment with a distance of 7. And then BY contributes a positive moment with a distance of 7 as well. Let's see what we have here. If we sum up all the first numbers, we get minus 69.64 plus BY, which is 9.95 times 7. This works out as 69.65. So there is a very slight difference there, but it is a tiny percent, and that is just because of how I've rounded up things along the way. So we can safely say that that is roughly 0, and therefore we have passed this check, and we can move on to solving whatever needs to be solved next. So that's another set of reactions solved, this time with a couple of point loads, one which was angled. I hope that helps. Please ask any questions if you have them, and that's it for now. So see you in the next one. Bye for now.